Hi class, this is Mr. Morris, and this is the first in a series of videos that are talking about the gas laws. This is for pre-AP chemistry. If you are in on-level chemistry, you can still watch this. It's going a little bit deeper than what you maybe need to in some cases, but it's useful, and it's kind of aimed for the more advanced AP-bound class, pre-AP chemistry or honors chemistry. So looking at this first page, we're talking about Boyle's law. This is our first gas law that we're going to address. Boyle's law says that if the volume of a container is increased, the pressure decreases, and if the volume of the container is decreased, the pressure increases. So this is an inverse relationship. As one goes up, the other one goes down, or as one goes down, the other one goes up, right? They're inverse relationship. So it tells us why at this point. Let's think about the volume. Remember, a volume is the three-dimensional space that a gas could be fit inside of. Okay. Now, if I increase that three-dimensional space, there's a greater distance between the walls of the container. So that means the gas molecules will hit the walls of the container less frequently. And if you remember when we talked about the kinetic molecular theory, we mentioned that collisions with the wall of the container is where pressure comes from. So if you have a smaller distance to travel, the gas particles will hit the walls more frequently, making the pressure go up. The opposite of that is also true. That's what it's saying here. If you increase the volume, there's a farther distance for the particles to travel. They won't hit the walls as often, and because of that, the pressure will go down. Okay, we've got our equation right here. We're going to be using this equation quite a bit. P1 times V1 equals P2 times V2. You want to be familiar with it. Again, we said it's an inverse relationship. That's an important thing to know. As one quantity goes up, the other one goes down. And the amount of gas, which is N, and the temperature, which is T, they're constant. Constant means it does not change. Don't get confused and think that some students get this confused with standard. Okay, the words standard and constant are not the same thing. Constant just means it does not change throughout the process, so we can kind of ignore it. That's why the equation only has pressure and volume in it, because moles and temperature, they're not changing, so we don't have those variables in this equation. Couple real life examples. The bubbles exhaled by a scuba diver, or even if it was just you swimming in a swimming pool, when you exhale air underwater, the bubbles, as they go up, they're going to grow. Okay, you've probably seen that. The reason is because as you get closer to the surface, the pressure is lower. And as the pressure goes down, the volume increases. Same thing is true with deep sea fish. Deep sea fish live down really low in the ocean where the pressure is very high. And as they go closer to the surface, the pressure is lower, and the lower pressure causes their volumes to increase. Unfortunately, they increase sometimes so much that parts of their body expand beyond what they can handle and they pop. And that kills these deep sea fish if they're brought too close to the surface. All right, let's look at this first example. So this problem involves Boyle's law. It has volume and pressure. It has two different values for volume and pressure. Remember, our equation is P1 V1 equals P2 V2. So we're going to label that out. P1 V1 P2 V2. Now we want to read the question and kind of pull out some of the data that we could use to solve the problem. First, I see 2.00 liters of a gas. If you remember, liters are a unit of volume, so that's going to be either V1 or V2. 2 liters of a gas is at 740.0 millimeters of mercury. That's a pressure unit, and it even tells us right here that's our pressure. Now it asks us what is its volume when the pressure is changed to standard pressure. So it sounds like this is our second, because it says changed. That's going to be P2 and V2. It's changed to standard pressure, and hopefully you know what standard pressure is, or at least you remember the idea. That's when we talk about STP, standard temperature and pressure. Standard pressure is 1 atmosphere. Okay, so that's P2, right? This is P2. P2 is 1 atm. But I want to change it to where it matches everything else. Let's write down our variables. P1 is 740.0. Don't forget your units. They're so important in a problem like this. mmHg. That tells me that atmospheres won't work. I need to convert this to millimeters of mercury. And if you look at the back of your periodic table, you'll see that 1 atmosphere is equal to 760 millimeters of mercury. All right, then I have V1 and V2 are the volumes. V1 is probably my starting volume here. It is. It's my starting volume, 2.00 liters. And V2 is what I'm looking for. Since I don't know that yet, I'm just going to put a question mark. And now, I'm going to draw a line. So I have my variables over here. I'm going to have my equation over here. P1 V1 equals P2 V2. So let's write it out. I've got 740.0 times 2.00 equals 760.0 times V2. V2 is my unknown, so I'm going to leave it as V2. Everything else, you just plug in the numbers that you have. All right, you need to crunch the numbers a little bit. Let's simplify this. 740 times 2 is going to be 1,480. Make sure you're keeping track of sig figs as you go through this. This is 4 sig figs. This is 3 sig figs. My answer needs to have 3 sig figs. It's the lower of the 2 numbers of sig figs there. Okay, and then I have 760.0 times V2. There's nothing I can do to simplify that. Just write it out. Okay. Now I want to solve for V2. These 2 numbers are being multiplied right now, so I want to do the opposite or the reciprocal of multiplication. That means I'm going to divide both sides by 760, so V2 will be by itself, just like if you were solving for x. So I'm going to say V2 is equal to 1,480 divided by 760.0. Just solving this algebraically. When you put that in your calculator, you'll find that it's 1.95. There's one more thing we got to make sure we get right, and that is the units. If you look back, I'm looking for volume. I had liters. That was my first volume, so my second volume is going to be giving me units of liters as well. So I have 1.95 liters as my final volume, and that's how you solve the first problem. There's a couple more example problems. I'll probably post an optional video that goes through those example problems, but I wanted this introduction to be fairly short, so I'm going to wrap it up there. I hope this was helpful. It's just an introduction to Boyle's law.